we are going to discuss about spirometer. The spirometer is an instrument used to measure the lung's capacity and volume, and the record or the graph obtained from this device is called a spirogram. Now, here we are going to discuss about three different types of spirometers. The first one is a basic spirometer. A basic spirometer is a classic water-sealed spirometer. It consists of a water-filled cylinder. Here is the water-filled cylinder and containing an inverted counterweighted bell. This arrangement is known as inverted counterweighted bell. Now, here there is an oxygen chamber. Breathing into the chamber varies the volume of the chamber. That is, volume of gas trapped inside the chamber will be varied. Now, according to this volume, there will be a vertical motion of this inverted counterweighted bell. Now, this vertical motion will be recorded by using an instrument known as kymograph. A kymograph is a device that draws a graphical representation of spatial position. That is, the kymograph consists of a drum, a revolving drum wrapped with a sheet of paper on which a stylus moves back and forth. This is the stylus. The movement of the stylus will be proportional to the movement of the inverted counterweighted bell, and that in turn is proportional to the volume of the air in the chamber. That is, as the patient breathes, the volume changes. Proportional to that, the inverted counterweighted bell motion vertically moves, and that vertical movement is recorded by using the stylus draws that motion on this kymograph, on the paper of the kymograph. Thus, the graphical representation is obtained. So, that was the working of a basic spirometer. Now, we are going to discuss about the next one, that is a wedge spirometer. The wedge spirometer consists of two square pans. This is a square pan parallel to each other. Two square pans which will be parallel to each other. They will be hinged along one edge. Hinged means attached with something. Attached at one end. The one of the square pan is attached to a stand. It is permanently fixed, and that consists of an inlet tubes. There will be two square pans. One will be attached and it will be having a permanent stand, and also it consists of inlet tubes, and the other pan swings freely. The space between the two pans is sealed airtight, and it consists of bellows. These bellows are extremely flexible. That is, when a pressure gradient exists between the interior of the wedge and the atmosphere, there will be a negligible distortion of the bellows, and this distortion of the bellows makes the moving pan to change its position. Okay. So, the movement of the bellows or distortion of the bellows makes the moving pan to change its position. Now, the volume and the flow signals are obtained by using two transducers attached to the fixed frame, and the transducers are also coupled to the edge of the moving pan. One transducer produces a DC signal which is proportional to the volume, that is the displacement or volume, while the other transducer produces a DC output which is proportional to the velocity or flow. Now, these transducers output are connected to electronic unit and a pointer attached to the moving pan, and a scale fixed to the frame determine the approximate volume of the volume position of the spirometer. Now that was working of a bed spirometer. Next we are going to discuss about the ultrasonic spirometer. An ultrasonic spirometer. So an ultrasonic spirometer utilizes a pair of ultrasonic transducers mounted on opposite sides of a flow tube. Suppose here this is the flow tube. Two transducers will be attached at opposite sides of the flow tube. These transducers are ultrasonic transmitters and receivers. Now both of them will be sending ultrasonic signals which will be received by the transducer at the opposite side. Now if there is no flow of air inside the flow tube, what happens? The transit time of both the signals, that is the upstream transit time and downstream transit time, will be same. But if there is flow in one direction, what happens? The transit time will not be same. The movement of the ultrasonic waves in the direction of movement of the air or gas will the time required will be less than the time required in the opposite flow of, if the flow of gas in opposite direction of the ultrasonic waves. And so if there is movement of the air inside the flow tube, what happens? There will be change in the upstream and downstream transit time. So from this upstream and downstream transit time, we can calculate the average gas velocity, and here there are the equations for calculating the average velocity. So that was the principle of an ultrasonic spirometer. So we have discussed three types of spirometer. The spirometer, which are the three types that we have discussed? They are the basic spirometer, wedge spirometer and the ultrasonic spirometer. Okay, thank you.